Hey, everybody. Good morning. My name is Wallace Tran. I'm a marketing manager here at our processors division within Texas Instruments. And I have with me also Vaibhav Mahimkar, who's another marketing manager for the other half of our processor portfolio. We're very excited to share with you today what our Vision AI processors look like. These are somewhat newer releases also, and we want to share with you a lot of what we have today and how we can enable you to make really cool Vision AI products. So we are based out of Dallas, Texas in the US, and very nice to meet a lot of the friends here in Southeast Asia. So of course, we will go through this, but at any time, please feel free to enter questions and our team will help to position it. So I want to share with you a quick one-pager, a lot of words, but of course you will get a copy of this later. But just a quick overview. And we talk a lot about vision because in our class of processors, this is where it's the most valuable. Vision processing can take a lot of compute power. So we want to talk about ways that our devices, both the architecture and the accelerators, make it easier to do AI processing, or even if you don't use AI processing, that is okay too. But there's a lot of things that require high-speed image acquisition and processing at low power. And especially in today's trends, we know everybody is trying to do more at the edge. So not having to go between a cloud and a server, a lot more of the processing can happen on the device at a low power, running on battery for longer periods of time. So this is what we're enabling here. And we use accelerators, hardware accelerators, in addition to our ARM cores. So we have a lot of collateral here on the bottom left, as you can see, and definitely you will get a copy of this so you can go through it. Also, ti.com/edgeai is one of the pages in that link that is basically our technology landing page. And that can take you to a lot of the other things that we have to share with you. So on the right-hand side, you can see even less than 3 watts of power, up to 5 watts and above for just depending on a scalable amount of performance and power consumption for integrated power efficient deep learning and vision accelerators along with DSP cores. So we're going to talk a lot about the deep learning side, but also the vision side, and also some of the other things we're working on in that area, and also show you some demos and some examples that can show you, giving you an idea of both where we have customer designs and also what it can do for you in your design. And one important part is TI, the strength we have is the scalability of the family of our processors. We have low end, mid end, high end, and just, we're working on other devices in this family also that will fill in some of the performance gaps, as you can say, right? Like maybe more mid high or mid low or even low low or high end. So, but no matter what, in that case, we have one unified SDK. So software development kit that will be same. Your software investment can be the same across all the devices, and you can just choose the device that makes the most sense for you. And lastly, the fast development is also very important. AI development is only fun when it's easy, and we want to make it very easy for you. And we've given good feedback. We want to share with you some of the tools we have, what that looks like, and we work very hard to keep things very industry standard. So no matter what evaluation platform you were starting with or coming from or production you were starting with, you can transition easily to what we do and have a very scalable portfolio option with TI. And we also offer a lot of pre-trained and optimized models, right? If you choose to go the AI path, and we will talk about that also. So we'll have this is a quick sneak peek, right? So the name of this family is AM6. So here we have a 62A, 68A, and 69A for analytics. So stands for analytics, of course. And these devices also have non-analytics versions of them for other purposes. But this just shows one part of the huge TI processor portfolio family. We talked about vision, and I want to dive into here a little bit more. So if you think about the cores and the accelerators on our devices, mainly is divided into ARM Cortex-A cores and also some deep learning accelerators. And there's actually another piece for vision, but I will kind of leave that for another section in this webinar. So this shows where the Cortex-A cores really come handy. And this is really nice because a lot of people are familiar more with Cortex-A cores. It's an industry, very standard, very popular type of core. People are used to programming in them, whether it's in Linux or whatever OS you've already been using, any kind of open source things. And if you think about the modality, which means like the type of analytics this is, camera vision is where the most of the value and where most of the market sees in this level of processors. You know, not only within TI, but even within the industry in general. Like at this type of processors with this kind of performance, camera vision is where it's the most valuable. We do audio and speech also. This is also a very important modality in another vector that is very important for analytics. Usually you see this a lot more in the MCU side, and we support that also somewhere in our portfolio. But we also have demos that involve doing audio and speech detection and recognition on our devices also. And then there's other time domain type things that can happen here. So obviously the Cortex A cores can do some amount of the processing in a general sense, in a very open way, but also our deep learning accelerators or DL accelerators can really, this is where you really get the power benefit, speed benefit, accuracy, just so many different things that you can get with these accelerators. And I won't walk through this one so much. You can read it later on your own when you get a copy of these slides. But right now, there's a very, I guess, conventional computer vision method of doing vision processing, I suppose you can say. That's probably what the industry has been using for a very long time. And, you know, there's this very big push towards deep learning. But, you know, not everybody is ready to go that way. I show here the benefits and the downsides of each, right? Obviously, a lot more benefits with deep learning, especially using TI's Edge AI, both the devices and the tools. But, you know, both ways can work. And we have examples of both happening. But definitely with deep learning, there's just a lot more, it could be shorter development time, could be just more accurate for certain complex tasks if you train it correctly, more robust to environmental changes. It utilizes, can be lower power and everything. So I think that switched on its own. That's okay, but I was ready. So I want to show with you here our processor portfolio synergy. I talked about the 6.2, 6.4, 6.8, and 6.9. This is just to show that, you know, signal processing, what we call for analytics, is one segment of a wider family. And there's more devices even outside of this. But just to show where that scalability comes from, you know, you can see the low, mid, high. We do general purpose, which has a lot of displays and multimedia. Actually, if you notice here within the signal processing side, it's an addition on top of the devices that we already have for general purpose. So a lot of the HMI, displays, graphics, video, codec, streaming, all these things. This is an option. The 6.2A, 6.8A, 6.9A adds like vision AI capability on top of that. Okay, and this is another way to show kind of the X and Y axes. One way you can look at it, and there's many things that I can call these devices scalable, right? Both in the A core performance, like 6.2A has A53s, 6.8 and 6.9 have A72s. So obviously 6.2A will be more power efficient. There's more low power modes available there. But you can see also the number of cameras that it can support natively. And you can see that for certain applications, maybe you will need more than 2 cameras. Maybe you will need 8 cameras. Maybe you need more. You need up to 12 cameras. And then the TOPS is another number people use for AI specifically. And TOPS is not always the most accurate and best number, as some of you AI experts may know, but it's a very industry standard marketing way of talking about AI performance. But we'll share with you the TOPS in terms of, which stands for teraops, you know, operations that it can do per second. But really, the inference time can be better than what you see in competitor. And there's ways, we have tools to show how that can be possible for you. So I just want to show that scalability, but at the same time, we're confident and we know when you have the numbers to back up that we have seen better inference performance on our architecture that's built for it versus competitors. Right? So scalable portfolio again, and there's more. You can kind of see strategically there are some gaps in this graph that we are filling in the very near future. And then also integrated ISP, image signal processor. When you talk about vision AI, this is very important because the quality of the image, whether it's machine viewable or human viewable, is very important. And you can save a lot of costs in other areas of your system if you have a great ISP on the chip. Otherwise, you have to buy camera sensors that have ISP on their own, and then it gets more complicated, right? And so for us, we support both RGB, it's a red, green, blue, also with IR and some of the choices. So infrared, usually good for kind of, monitoring of a person or low light conditions, perhaps. Um, you can see a lot of industry AI frameworks and models. Cloud tools will demonstrate for you in a second how to train models. And another thing that's shouldn't be underrated is the hardware and software partners that we have to accelerate the schedules. Like we know, you have a lot of projects going on. TI support is awesome. We spend a lot of time and resources into doing that. But I know a lot of times you want to be able to get something done faster with some help or something, in the community, something in the open, or even another partner that you trust already to do certain things for you. Developing a project can take a lot, but having partners to help with different areas of expertise can really accelerate a schedule, and you're not always, waiting on something to happen for you, right? You can go and find these partners. We have a lot of recommendations. We have an ecosystem that can provide the boards or, certain software support, and that's another key thing. And as I mentioned earlier, type in ti.com/edgeai, easy to remember, and that will lead you to our technology landing page that shares everything that we're going to talk about in this presentation and just allows you to go through it on your own with your own, control of, time whenever you have time and to play with the things yourself. We make it very easy to do so. And this beautiful slide here, Vision AI applications. It's a range of applications that can happen. Probably don't need to walk through every single one, but I do talk about low, mid, high here, talk about the different areas and applications it can be in. So a lot of things in the factory, smart factory and automation, that's a huge area. Smart city or construction and agriculture is another big one. So there's a lot of different things happening here. And, if you think about the market, a lot of times the Vision AI especially are doing object detection, image classification, or semantic segmentation. Those are usually what you do with these types, and we support all of them. So you can see detection and classification, right? So for example, doorbell would be one example. Warehouse packaging, right, tracking, right, text recognition. That's also very big for the speed and the accuracy of high volume of boxes going through a factory. And also things like fixed camera video surveillance, traffic light dynamic response, motion detection, pose estimation. We have demos on GitHub, a public software repository for you to copy, clone, and just be able to play with yourself and make powerful applications out of it. So here we divide into 3 really important pillars for Vision AI platform. And we talked about some of this, right? So the Edge AI product, that's where you start, because without the product, you can't do a whole lot. So silicon, EVMs, and SDK, right? We have all 3 of these available, easy to order or, easy to get from ti.com. Edge AI dev tools is another thing. So we're going to talk about some of the software tools. And then, as I mentioned earlier, the image sensor and tuning tools is another important area when you're talking about Vision AI. Because a lot of times you can get an image or a picture from a camera, but to tune it, we provide great resources and support and training on how to do that. Because that ultimately will determine, right? So if you're doing video surveillance, for example, it is important that you can operate in a range of conditions, right? Or what if someone is, in daylight or in nighttime, right? So you got to be able to do all these things. And the robustness and the reliability of your image signal processing is very key. So the TI Processor SDK is another one that is very, a lot of great things and great reasons to be using it, of course. So not only do we have a complete SDK ready to use, contains all the drivers, operating systems, middleware, libraries, and examples. It also enables a lot of SoC features and getting into entitlement, right? Because, honestly, processors can be a lot very featureful, right? These are very powerful, can do a lot of different things. And we basically can produce our SDK in a way that makes it possible for you to use all these things. So it's a great starting point because if they're, what we found is, when you don't have great software support from the silicon vendor, it becomes quite challenging because to be able to need something and getting a new feature added can be a while. But luckily for our processor SDKs, right, they've been, time tested. A lot of features been added, more are coming, but we've seen and we can continue to improve it. Professionally developed, and also like just great support in general, right? We can talk about E2E as another area. So we have a forum with all the things that not only can you ask your own questions, very big chance someone else has already asked the same question and got the answer. So you have such a great wealth of library of answers of just troubleshooting, different things that people will normally run into. And the last part is, it's our strong belief that a lot of these things should be free, right? Royalty free, no NRE. Our SDK is wide open for people to use, open source software licenses, and there's no hidden fees either, right? Because at the end of the day, we are proud of the product, right? Offering in general, but the software is something that you use to enable the product. So for a lot of this, we invest into making sure that we get good software and it just works for the device because ultimately the product is their device, right? So that's the TI Processor SDK that we offer. And then ecosystem partners can help with a lot of the other things, right? A lot of application-specific things, like if you think about robotics, may require like some SLAM algorithms for localization, mapping, and whatnot. Those are very much more application-specific, and we have great partners that help people use that and even go to production with it, right? We have some of these hardware products that are like SOM, system on modules, and those are actually production tested, production ready. You don't have to do board design. You just get the board from them, and they go through all kinds of reliability tests that are fit for production. And some people just need some engineering services. Maybe they don't have the software staff and whatnot. We have a few partners that we've successfully recommended and taken our customers through to production, and that has been also a great situation. Okay. And here we dive into a little bit more of the details of what each device can do. We actually will show some block diagrams later, but just to show when I say low, mid, high, what does that actually mean? So the first one is you can kind of see 6.2a, 6.8a, and 6.9a, right? And there's some companion devices around it. But if we focus on those three types, you can see that, when you select processors, one of the first things you do is what are the application core performance like? So this would be the A cores, like the A53s. We have scalable from 1 to 4 A53 cores that could add up to 18K DMIPS, which is kind of a dry stone MIPS, a way to measure the performance of your A cores. And then if you need more performance, we have A72 cores, which are actually very powerful. And you can have 2x, and that could be 25K DMIPS, 50K DMIPS if you have 4, 100K DMIPS if you have 8. And we talk a bit about the ISP and LDC. So image signal processor is like one of the accelerators that we have for image signal processing. LDC is lens distortion correction. That's an interesting one also if you use like wider angle lens. So we have a demo where we do video conferencing, for example. And if you think about you're in a conference room, you have one camera, needs to show a lot of people, but you don't want to have like so many cameras. So you just have one camera, it does a wider view, and you can correct some of that wideness when you process it. Stereo vision, optical flow, we have accelerators for that. And also video encoder, decoder, right? Video streams, that's another big one and important one. So unified SDK, right, across all these devices, similar architecture. So the way I like to describe it is the architecture is the same. So once you get familiar with one, you automatically have an understanding of a low, mid, high for our architecture. Basically, what we do is we just add more blocks or less blocks, depending on if it's low, mid, high. Okay, and here for ecosystem, I'll hand it off to my counterpart, Vaibhav.
Thank you, Wallace. Hope we can use the same mic. I'll jump straight into the next slide. And did it go one further? Okay. So we talked about the device portfolio. Wallace walked through the devices that we have for the Vision AI, which primarily focus on the camera and AI implementation on the embedded devices. We launched this earlier at Embedded World, and we launched it as an entire platform. What that means is it is not just the device and the documentation and a standard Linux-based SDK, but we also give you tools that are required to implement the AI on the edge devices. And this part's a very important piece for our customers to be able to deploy any kinds of smarts and intelligence applications on the vision or camera streams. So that is what we mean by an entire platform. It enables our customers to easily try out, evaluate the devices, the performance for any one of our devices on the AI models that we provide, AI models that the customer wants to try, and being able to see that without even having to have an EVM in hand. So the Edge AI Studio is a big piece of our platform level tool offering for AI. This is one common tool that covers all the devices that we looked at earlier on. You can, with just a TI account, not even have to install any piece of software on your machine. Just log on to this link, be able to log into any of our remote EVMs, get a session, and see for yourself how the AI model performs. So this is a big enabler for us that our customers are using today to be able to see what the performance of AI model is, whether you're doing object detection, whether you're doing any kind of AI model for understanding people's behavior, counting the number of people, different kinds of objects in real time. You'll be able to see and access these modules free of charge. You'll be able to load your own models and see the performance. You can compare the performance of these various models. We give you free reports available to compare between various devices, and you can compare these with industry standards. So with the entire model library that we provide, being able to compare and contrast the performance, all of this is possible. The other big piece that Edge AI Studio does, and we will walk through slides one after the other to see snapshots of how that is done, to deploy or develop models of your own and deploy them on TI's hardware. So we make it very easy, whether you are a new user for AI implementation or you are an expert in terms of handling the AI model development. This one-stop tool lets you do everything from evaluation to the final deployment or updating your model. So we highly encourage you to log on and try it out. There is no commitment. It's easy to evaluate and go through. One of the big pieces, and you can see here, is we rely on the industry standards to bring AI to the development community or devices that we have. So if you see the logos here, ONNX, PyTorch, TensorFlow, TVM, all these models are what we support on our devices. And you don't even have to code these individually. Just pick any of these models and take it through our tool and deploy it easily. We make it as easy as that. On the right-hand top, as soon as you click on any of these logos, it takes you to a simple form that lets you select which device are you deploying for, what kind of AI model are you trying to use. And then it is a GUI-based click-through model, easy to understand. No special documentation is needed. It's an intuitive tool for you to deploy and develop. Okay. The tool internally is made up of two different components. One of them is the model maker. As you can see just by the name, if you want to make a new model of your own, this tool lets you do that. The GUI interface will let you bring your own model, customize it further, pick any of the trained models, add more data to it, make your own, make it unique for your application. Once you're ready and happy with the performance, you can take it through compilation step. This is what the model maker allows you to do. Once the model is ready, you can deploy it onto the hardware, which will be easily deployed on the chain that we have, as we provide as part of our examples, or the SDK kit, and you'll be able to see the performance of that model in real time on the device itself. We also host all of these model libraries on our GitHub. So there are hundreds of models already compiled for you to deploy on TI's devices. So this together forms a very easy evaluation tool, ready to deploy, and cuts your development time very short. The next few slides, we are going to see how the GUI looks for the Edge AI tool. This is a very important piece, so we wanted to give a little bit more focus on what each of these tools snapshot looks like. As you can see, once you log in and choose a tool, it's as simple as making a new project. You decide what kind of detection model you want to run, click, next step, start a new project. If you want to, in this case, we're talking primarily about the camera-based system. So if you want to maybe capture a few images of your own using the PC that you're using, or you already have saved some on your desktop, you can easily load that database into the tool. So upload it onto the tool, be able to tag it. Those are the next steps that we'll see. But there are various ways to load data, which is one of the big things for AI models onto these tools. Once your data is available, and we are talking about images in this case, various images that are there, you can easily tag them, mark them, whether it is different kind of objects, maybe there are flowers, fruits, human beings, animals, colors, various colors and objects and shapes, all of those could be tagged. And this is one of the tools where today we see a lot of players in the industry charging. To do this, we give you a very free tool to do each of these things right within your PC. No need to install anything, just the database, and TI gives you all the compilation and the easy to deploy steps for it. So let's say your data is uploaded, you're making a new project, you have selected which data and tagged it correctly. All you need to decide now is which device do you want to deploy it on and what kind of model you want to use. The left hand side lets you choose from one of TI's devices, and we continuously add more devices to it. And the right hand side will let you choose what kind of model you're choosing. If you know already which model you're interested in, you can quickly choose that. If you're wanting to choose a specific model, you can either do the auto select or choose the model of your size and then deploy on TI's device. So next step is the step that does the actual compilation of the model. It'll give you results. It'll take the test database and the training database, compare it with each other, and tell you how well the model is trained for that particular model that you have selected with the database that you have. And then I double click. So once you're done with the model compilation, you're happy with the kind of results you are getting. Next step is to download the compiled model onto the device. And this is the GUI that lets you do that.
Is it still flickering in there? I think they were saying the slides may be flickering between 12 and 13.
12 and 13.
Oh, that was actually some time ago. Okay.
Okay.
That was like 4 minutes ago.
I hope the slides are still clear. If we need to go back to any of these slides, please do let us know.
Thank you for letting us know, though.
So in this case, we have tagged a database of various kinds of objects that we have tagged as good and bad. And when put in a picture or image in front of you, they are automatically detected based on the model training. So the results in this case that we see are from the device that is using the trained model that we just created and using. All of these are available as training documents on some of the links that we'll show. We'll share them with you through the slide deck. But on and whole, Edge AI Studio is one of the big commitments from TI to make our developers or customers' life easy for AI development. It's a common tool where we see a lot of competitors and third parties charging money to make these happen for their devices. From TI side, it is a completely free offering and a very easy to use, leveraging industry standards. As part of a portfolio of the platform, we make available a lot of easy to implement examples. Some of these are created by our fellow engineers in TI, our applications team. Some of these are created by the third parties that we work with. They deploy these models on TI's devices and make it available for our customers to use. All you need is to log in, have an hardware in hand, just download the images that we provide here or the models that we provide here. Each of these links will walk you through a step-by-step flow of how these models can be deployed on TI's hardware. And there are a variety of examples, and we will walk through some of those examples, but TI-Rex, and you can see the link as easy as Wallace said earlier, ti.com. In this case, it's /edge AI projects. Every AI project that we make available is uploaded here, and we have a big community of TIers and followers from outside of TI who frequently use and deploy these. Along with the examples and the software, we also provide training data. So our collateral, not just for the device, not just for the SDK, but what is AI? How to make a simple project like a Hello World equivalent for AI, how to deploy the model onto TI's device. There are step-by-step trainings for each of these. And these are available even in video formats. Along with the documentation, there are relevant links to some of the videos that will be very helpful for anyone who's interested in knowing more to go deeper into the data and the details of these. Now here's a quick snapshot of all the collateral that is available from TI or start points for each of these collaterals. Either you're trying to go more into the details of the device offerings that we have. So we have listed our TI's AM6XA folder set. So 2A, 68A, 69A, all of these with the product links are listed here. As simple as you can copy them from here or just find them to TI's processor page. We looked at some of the training material that we have, the AI projects, the Edge AI Academy, which is documentation and collateral. And along with the AI demos, there is a huge repository of robotic platform demos. So whether they are moving robots, moving arms, static robots that are trying to pick and place objects, all of these are available under TI's Robotics Academy. A link for that is shown on the screen here. If you had to remember just one link out of all of this, it's ti.com/edgeai. Any other resource that you need to find about camera-based processors from TI, AI processors from TI, this one link will take you to that, ti.com/edgeai. So I wanted to call it out again. This will take you to some of the training examples as well, some of the documentation that we have for our devices. We have a few more examples that walk you through some of the implementation efficiencies and benefits of TI. We have done this for some of the examples of single and multi-camera, but they call out how efficient the operations can be on an equivalent TI-based Edge AI processor. Some of the links are here. We'll share with you all of these offline. Each of the devices that we saw have an evaluation module. Primarily, it is also known as an EVK or an EVM. So the links for each of these are listed here, the SK-AM62A, SK-AM68, SK-AM69. These are the locations where you can easily buy an evaluation kit for the devices that we talked about today. And again, the link for the studio, which is the AI development tool, is listed out here. Of course, TI's engineer-to-engineer forum is available for any one of you to post your questions, and the fellow engineers from our company answers these questions. So e2e.ti.com can be a great resource if you want to get started and have any questions around it. I think the next step is we go through some of the examples that are available on the resource that we saw earlier. So I'll hand it over to Wallace again to get started with these.
Okay. Let me hit next. We're going to walk through some of these demos because this is the most powerful way for you to visualize and see what can really be done here. So we run it on certain devices, but there really are a lot more, like I said, it's scalable. You can run it on the other devices too, right? Just with different varying kind of performance. So the first one is we do one with license plate recognition. So these are trained on some Indian plates, as you can see, if any of you have been there. So this is shows quite a few interesting things there. And, you know, you can think of license plate detection and recognition as one thing, but you can start to brainstorm also other ideas that this could be used for barcode reading in a factory or anything like that. And this was run on the SKTDA4VM device that we have, which is kind of like the SKAM68 level, so mid-level device. And there's a GitHub here you can click on that will take you exactly straight to the source code so you can run it on yourself. And they show you how to train more as a README and a guide. So that goes for all of these examples. But license plate recognition is one that's quite interesting for a lot of people because this is where you really start to feel and see, using text or kind of image and making inferences out of it. One other one that's very exciting and growing very fast, and here's a video. I won't show it, but if you have the slide, you can click on this video. There's actually one on the TI.com videos, and the same video is on YouTube as well. So any kind of open that you can play it on your phone or whatever. So autonomous mobile robots, right? This is a big one. I'm sure you see a lot of these factory robots. If you see this picture in specific, right, of the video, you can see this robot is going through a factory picking up packages or kind of some kind of weight, right? So you put things on top of it, it raises and things like that. So what's also really cool about robotics in general is TI, even outside the processors we're sharing today, have so many capabilities that TI also sells devices for. Motor control, safety, that's really big, right? The SIL levels, like SIL 2, SIL 3, we support any kind of PLD, PLE, Cat 3, we've done that before, so definitely worth deeper investigation if you have any of those type of questions. But we've supported designs in all of those that gone to production. So this example here is actually using radar and camera. So not only just camera, right? Our devices can do more than just that. So TI sells the radar sensors. We sell the motor control MCUs and the gate drivers and a lot of the other stuff. This one even uses a DLP-based HMI module. So it's a very powerful demo. This was shown actually in CES earlier this year in January. So this is something that shows the capability of this device. And there's ways to extend this project as well, right? In robotics, you can do SLAM, you can do all kinds of kinematics, different kind of algorithms. But the possibilities are endless. And I wanted to share with our autonomous mobile robot demo here. Here's another one interesting too, Cobot Arm. So this is one where robot arm is everywhere in any kind of factory situation, maybe even outside. Here I put the links here for the TI.com video version that's on public web, and also the YouTube one that you can definitely find publicly anywhere. So this was a demo that we showed quite a few times. So we have a TechMan arm. So basically this is a cobot. It's kind of a version of a robot. So this is one where cobots mean collaborative robot, and that means it's meant to operate next to people and interchangeably, and it's like not dangerous for operators to be next to it. So we show here the different kind of things that are there. The radar sensor here. So basically using radar is easy to tell if someone's coming towards it. So if someone walks too close, then the robot arm stops moving. We have the processor here, the TDA4VM again, kind of like the AM68 class, but could run lower, could run higher depending on what you need to do with it. Here's a camera to detect the operator movement. So this demo, specifically just for demonstration purposes, you can see this picture of a screen capturing one of our engineers. It tracks the motion of his arm, and the robot arm moves in the same way, right? So think about a robot arm doing like a kind of any operation, right? It's following his arm, and then if it gets too close, then it stops tracking the person's arm, so for safety reasons. So this is one that we're looking to publish some source code on the web, but we've shown this demo also quite a number of times. So this just shows the capability of what TI's portfolio can do, and also that this gives you some ideas of what projects could be adding and using AI for this. So this kind of uses like a gesture recognition type of inference of AI. Okay, you want to cover this one, defect detection?
Sure, no problem. Let me separate this. So we are continuing on the examples and the demos we have. In this case, we have made an example that is relevant to a production line or an assembly line, which needs real-time decision making on the fly. And earlier when we were talking about the Edge AI Studio, you must have seen some of the images. They look similar to what we are showing here. So this is done by one of our engineers here using the Edge AI Studio tool that we talked about. We picked objects with a few defects in there. So we picked a set of objects which we called as the good set of objects. And with some of them missing a ring or having a different color, we call them out as not compliant objects. So if you see, once that training was done, it was then deployed in front of the camera. The model is running. If you see on the left-hand top side, when the table rotates, it is similar to a conveyor belt, bringing all these parts in front of the camera at a very good speed. And at one shot, this camera can detect which object. It can isolate the object, decide if it is a good object or so-called bad objects. And these are the decisions that the device is doing in real time, using just one device and making sure the models and the cameras are running at the required rate. These can be applications that this can be used for applications that require single or multiple cameras and can do such kind of detection, maybe in assembly, maybe in production facilities, maybe trying to understand if the device is correct up to the quality inspection levels that is required, and then take quick actions, whether to take it out of the plant, whether to make sure it is replaced with something else, so it does the bad quality part doesn't go ahead. So these are very quick implementations done by our team, but it shows the strength of our portfolio and how relevant these examples are to some of the common manufacturing and assembly units. And again, this device, an example, is available online. Actually, all of the examples that we are looking here, they are called out on TI's Resource Explorer, which the links are was shown earlier, for anyone to deploy on our device very easily. And we walk you through the steps, how to get the software, how to connect the EVM kit or EVK from TI, and recreate these demos on your own. Another example, this is based on camera-based object detection. So objects are trained, or the dataset was trained with various objects that you would see in a cafeteria or a general store. So at a lot of places, such kind of self-checkouts are happening. Everybody is aware of Amazon's Go store, where you do not even have to go do a checkout. Just put things in your basket or a bag and walk out. Similar to that, we see implementation, a lot of self-checkouts. So think about airports that do not want to employ people or just want one person observing multiple counters. So these are great examples where automation is coming in and how TI's products is enabling that deployment today. So similar example there, you just have multiple objects in front of a camera, and that detects what object it is, and it will be able to create a list of things and automatically tabulate what is happening. This can be done for inventory tabulation. This can be done for self-checkouts. Think about automated superstores. I think if you have visited any of the Walmarts or the Targets here in the US, and I'm sure even elsewhere, you will see automated teller stores, right? So these are the examples to enable those. And our devices and our portfolio are enabling that today. Similar example, in this case, we are trying to show barcode or a QR code. Now you can see with help of AI, we are able to isolate where the barcode or the QR code is, and on top of that, be able to recognize what that code says. This can also be used at self-checkouts. You can use one or multiple barcode cameras. You can do multiple cameras looking at the same object. Similar example to what we saw earlier, but a different domain. And one of the things you must have noticed, everywhere you see, we have a few bars of performance that are screens with the running images call out. They're actually showing how much of the AI accelerator or the ARM core is being used on any of these devices. You will see some of these are implemented on devices that are not meant for graphics, but they are doing the graphics just to show what is possible. In our portfolio, we have varying levels of compute, varying levels of graphics, varying level of ARM processing compute available. So based on your requirements of the application, the right processor can be used here. But as you can see, a lot of compute juice is available, but it is not being used by the AI model that we are showing here. I think,
and I'll take the last one here.
Sure.
And then basically, pretty much last slide before we go into the Q&A section. So please feel free to roll in more questions and we'll answer them all in their Q&A section. We'll leave about 10 minutes for that. So the last one I want to share with, we kind of talked about a little bit earlier, but there's a pick and place demo. And in a factory setting, this is a super common use case, right? Thinking about just moving from one to the other. And it will actually, this demo, I've already seen it work. There's a video internally that we're working, that we have, but we're working some through things before we push it out publicly. But this is a great idea to show you the capabilities, both of the traditional CV, which computer vision, and also the AI type things, right? So, being able to locate an object through video, then able to move an arm to the position, and based on what it recognizes, it could put it in different places. That's what I've seen the demo do. And there's different arms that can do this. This is also where it used like ROS, so robotic operating system, like framework. And this runs on the SKAM69A, but it could run on something lower as well. So you can see that look at the flow of this, right? You're looking from a monocular camera, going through the LDC, the image correction that we talked about earlier, then doing the pre-processing, kind of all the key point detection, feature extraction, and running the inference on it, and ultimately doing a robot command where it's going to move and take care of the arm accordingly, right? So we have a desktop version running on the Nereo arm, and there's also one working on with the TechMan arm. That's like a much more industrial grade, bigger looking professional arm. And that's shows the different blocks also. As Vaibhav alluded to earlier, he shows the loading on the different ones. You can see that a lot of it is actually utilizing some of the accelerators that we have to make it a lot better. And a lot of times, like even when you see the loading on our demos, because we like to put the bar charts at the bottom to show like what percentage is being used. Usually the A core is mostly for like the graphic side of it. A lot of the times the inference and whatnot is already done with the accelerator. So depending on what you're trying to show on a display, it could be less or it could be more. Right. So then here, which lastly, I'll flash this last one, and you can have access to this also. But there's an ISP tuning tool, and this is very important for just enable our customers more broadly, because a lot of times this ISP tuning, doing certain settings, color correction and whatnot is going to require some kind of training or tool. And we already have public app notes for these for ISP tuning, right? Depending on what device you're using. So feel free to check out both of these app notes for different devices, but roughly the instructions will be the same.
Maybe a good point for question answers if you want to.
Yeah, I think we just hit the good time for switching over to question and answers.